Right, I'm just getting started on an experiment for a new way to power the laptop. Now, I previously used a UPS, a mini UPS, and a self-made battery pack. And I was always a little worried that, like, if I can't sell them because I don't have the equipment to test and make sure that the lithium-ion batteries are the high quality that they're supposed to be. Poorly manufactured lithium-ion batteries have a tendency to spontaneously ignite and even explode. Now, the lithium-ion batteries that I was using are less volatile, but can still be potentially dangerous. And I was worried that if let's say I sell the kit set. Without the batteries, people buy their own batteries. Sooner or later, somebody's going to buy bad batteries, and they're going to spontaneously ignite or even explode, and that's going to be bad for everybody. So I have this new idea. Here's a little circuit. It's a little USB-C with the power control protocol on a chip in it. So the idea is that I get one of those big battery packs. You can now get 100 watt hour USB-C battery packs that's the biggest that's allowed on an airplane. Plug that in here, connect that to the micro ATX power supply, and power the laptop that way. So what I need to do first is to connect it up to this wire, this cable, so that I can plug it into my laptop. So that's what I'm going to do next. I'm going to solder this up and then see if it works. It should, but you never know with this stuff. Right, so I can't just plug it all up and expect it to work. First I have to program the power device on what voltage and what maximum current I want. So I have this little microcontroller here and a program that should set it. So I'll just modify it, set the maximum voltage, or set the voltage to that I want to 20 volts and 5 amps. 20 times 5 is 100 watts, which is the maximum that it can handle anyway. And all going well. After it's been compiled and uploaded to this, we'll be able to set this thing and then move on to the next step, which is measuring the voltage. And then finally, an actual test. So we'll see, it says cannot connect. So you'll have to excuse me, I'll switch off the camera and see if I can fix that. Right, I've figured out what I did wrong, and I'd set the target board to the wrong one. So it was compiling for the wrong board. I've now corrected that. It says here that it's established communication with the power board and set it to 20 volts, 5 amps. The power LED here is lit up saying that it's got it. So right now, if we measure, we should be getting 20 volts. So let's see. And yes, we have 20 volts. So now we'll move on to the next step, final step for today, which is to plug it into the computer and see what happens. I have now plugged it into the computer that I plan on turning into a laptop. So assuming that everything's set up right and the communication back from this microcontroller says that it is, if I push the power button now, it should boot up the machine, no problem. So the LED's on. What about the screen? Okay, looking good. Yeah, okay, so it's working just fine, which means this should work. This should work well on the laptop. I can move on to the next step, which is to buy one of the power banks. Again, the reason I'm going to do it this way is because I'm concerned about the batteries. There's no real way to tell if the batteries you're buying are even manufactured by the company that it claims it's manufactured by on the label. And if anybody buys bad batteries, can get nasty. Here's an overview of what's planned. I've ordered a Hyperjuice USB-C battery pack, which has a capacity of 100 watt hours. There's a link to it below. Full disclosure, it is an affiliate link, so if you buy from them, I will get a commission, which will help fund this laptop project. That said, if you are considering to buy the battery pack for your own DIY laptop, you might want to hold off until I've had a chance to test the setup. Anyway, so the plan is there are 3 sockets on the battery pack. I'll use the 100 watt USB-C. It's both input and output, so you can charge the battery through that or drive something at 100 watts. Plan is to use that one to charge it. Then the USB-C output that's 60 watts will be used to power the motherboard via the little USB-C power sync board. And finally, the USB-A, which is maximum 18 watts, will go to the LCD panel and controller. Now, that does lower the maximum power that we can use, which is 78 watts, down from 100 watts. But if you think about it, USB-C's power delivery is currently maximum 100 watts. So first thing, if your computer is using 100 watts and you're trying to charge it with maximum 100 watts, you literally cannot charge the battery while your machine is using that much. And the other thing is that a 100 watt hour battery pack, if you're using 100 watts, it will drain in an hour or less, which gives you rather limited laptop usage time. So if you're somebody who wants to build like a gaming laptop out of desktop components, I highly suggest that you would use a normal ATX power supply, ditch the idea of making it battery powered, or get a bigger battery pack to power your machine with, and forget about being able to transport it on an airline. So we'll see how that works when I get the battery. Until then, see you next time.